Welcome to the Calculus B section. In this section we'll be discussing the fundamental theorem of calculus. Now, the fundamental theorem of calculus justifies our computation of evaluating an integral, or the antiderivative, at the upper and lower limits of integration, and taking the difference. Now, the fundamental theorem of calculus states that the integral from b to a, the upper limit to the lower limit, of f of t, our original function, is equal to f of b minus f of a. Now the relationship between little f and big F is as follows. F of x, little f of x, is equal to big F prime of x. Now this states that the integral of a function that has been derived, the antiderivative, is equal to the upper and lower limits within subtracted from each other. So let's try this in a problem. Let's say that f of x, big F of x, is equal to x squared over 6 from the intervals 1 to 12. This means that from b to a of f of t, we have from 12 to 1, 2x over 3 dx. Now, when we integrate this function, we state that 2x over 3 dx, the integral being x squared over 6 from 12 to 1, will give us 144 over 6 minus 1 over 6, which is equal to 143 over 6. Now, if we were to take the integral of if we were to plug in our upper and lower limits into our f of b and f of a and took the difference between the two, we should get the same value. So we know that f of x is equal to x squared over 6. Therefore, f of 12 minus f of 1 should equal 144 over 6 minus 1 over 6, which is also equal to 143 over 6. Therefore, our fundamental theorem of calculus checks out. Now, the fundamental theorem of calculus, all it does is prove that we can integrate from a to b of a function and to take the difference to find the area under the curve. So I hope that helps, and there's a bunch of resources on the website if you need additional information. Thank you.